All right. Good day, my viewers. Today we are still on systems of linear equation. Previously, we have looked at how to use Gaussian elimination method to solve systems of linear equation. Now, today we are going to look at how to use the Cramer's rule to solve that system of linear equation. And then later we're going to look at how to use the inverse matrix method to solve that system of linear equation. Now, I'll proceed by solving using the Cramer's rule. In the Cramer's rule, first of all, you must get the matrix. Let the matrix be A. Okay, let the matrix be, the quotient here is 1, you have minus 2, you have 1. And here is 2, minus 3, and 2. Here we have 4, 1, and 8. This is the matrix, okay? Then the augmented matrix is going to be 1 minus 2, 1, and then you have 4 there. Okay, here you have 2, minus 3, 2, and here you have 7. And here you have 4, 1, 8, 8, and then outside you have 19. This is the what? Augmented matrix. So we are going to look for the determinant of this matrix. The determinant of the matrix, let it be this, determinant of matrix. The determinant of matrix be represented by this, which is 1 minus 2, 1. Determinant of 2 minus 3, 2, 4, 1, and what? 8. Now let's go ahead to look for the determinants, and that is taking this as the leading one here, times, okay? Now eliminate the elements on the same row with 1 and on the same column with 1, and you are left with this, minus 3, 2, 1, 8. So we're going to look for 1 times the determinant of minus 3, 2, 1, 8, okay? Minus, there's a conventional negative sign that you bring in, and then you now bring in this minus 2, okay? And then multiply it to the determinants. First of all, I took this one. Conventionally, we have plus, we use plus, minus, plus. So I've taken plus 1 times this determinant of the remaining elements here, minus 2 times, eliminate 1 and 1 because they're on the same row with 2, and eliminate minus 3 and 1. You are left with 2, 2, 4, 8 times 2, 2, 4, 8 plus 1 times the determinants, eliminate 2 and 8 and minus 2 and 1. You are left with 2 minus 3, 4, 1, 2 minus 3, 4, and 1. Okay, so this should give us minus 3 times 8. Determinant of a 2 by 2 matrix is what we are doing right now in this little square bracket. Minus 3 times 8 is minus 24. Then minus 1 times 2. So we're having minus 24. Remember that 1 is outside. Minus 24 minus 2. You have plus 2 here. 2 times 8 is 16, minus, bring in a conventional minus, that's for determinant of a 2 by 2 matrix. 2 times 8 minus 2 times 4, which is 8, plus 1, bracket 2, minus 3. Okay, that is going to be plus 12, because minus is plus. So this is going to give us, we have minus 26 plus 8 times this is 16 plus 14. Okay, so this is 30, and that is what? 4. So the determinant of that matrix is what? 4. Determinant of the matrix is 4. Now let's get the determinant of this augmented matrix. Let's look at this augmented matrix. If I replace this column with this element, with these vectors, 4, 7, 19. If I replace it, it's called augmented matrix for X. This is called augmented matrix for what? X. Augmented matrix for X. So if I look for the determinant of this augmented matrix, 4 minus 2, 1, 7 minus 3, 2, 19, 1, 8. I'm going to have plus, minus, plus. Remember the conventional signs. We have 4 brackets. This time this is minus 24, minus 2. Okay, we have minus 2 is plus 2. And that will give you 7 times 8 is 56. Minus 19 times 2 is 38. Okay, you have plus 1 brackets 7 plus 3 times 19. You have 3 times 9 is 7. Take 2. Okay, that is 57. We have 57 there. Okay, when we add up, we have 4 times minus 26 plus 2 times 18 times 18, okay, plus 64. Okay, when we multiply, this will give me 4, take 2, 8, minus 104, okay, plus 36, plus 64. This is what? Equals to minus 4. So the augmented matrix, the determinant of the augmented matrix, okay, determinant of the augmented matrix for S gave me minus 4. Now let's also look at the augmented matrix for Y. I'll have 1, 2, I'll return the coefficients for X, then replace the coefficient for Y by 4, 7, and 19. And then I have 1, 2, and what? 8. This is the augmented matrix for Y. Remember that our determinant is 4. Determinant for X is minus 4. We've not gotten determinant for Y. That's what we are looking for. So determinant for Y, I'll clean here. Determinants for Y is going to give us 1, 2, 4, 4, 7, 19, 1, 2, 8. Okay, quickly let's run it out. We have 1 plus minus plus. Remember that, plus 1 in bracket 7 times 8 is 56 minus 38. Then you have minus 4 in bracket 2 times 8 is 16. 4 times 2 is 8. Okay, you have 1 there, plus 1 bracket 38. 38 minus 28. This will leave us with 56 minus this. You have 18. Okay, here you have minus 8 times is 32. And then you have plus 10. Okay, so this is 28. This is actually 28 minus 32. Which is what? Which is minus 4. 28 minus 32. 28 minus 32 is what? Minus 4. So this one is giving us minus 4. It's remaining the augmented, the determinant of augmented matrix for Z. So I'm going to clean here. I'm going to clean here. The augmented matrix for Z. Here is the coefficient for X, intact. quotients for y are -2, -3, and 1. The quotient for z, which is 1, 2, 8, will now be replaced by 4, 7, and 19. It will be replaced by 4, 7, and what? 19. This is the augmented matrix for z. So we go ahead to look for the determinant of that matrix. Determinant of the matrix will give us 1 minus 2, 4, 2 minus 3, 7, 4, 1 what? 19. Okay, that will give us 1 bracket. This is minus 57. Okay, minus 7. And then you have, remember it's plus, minus, plus. So here you have plus 2 brackets, 38 minus 28. And then you have plus 4 bracket 2 plus 12. 2 plus what? 12. Because we have 2 times 1 is 2 minus 12. So minus 12 is plus 12. So the whole thing will give us, this is minus 64 plus, here we have 10, 20. Here we have 14. 14 times 4, I have 6. It's 56. You have 56. So this is actually minus 64 plus 76, which is what? Which is plus 12. Which is plus 12. So, which is plus 12. So that means that one is giving us plus 12. Okay, so what do we do now? Our x, the value of x in that equation becomes the augmented matrix for, determinant of augmented matrix for x divided by the original determinant of the matrix. This will give us minus 4 divided by 4. From that data there, we have x is what? Minus 1. And y becomes the augmented matrix, determinant of augmented matrix for y divided by the original determinant, which is minus 4 divided by 4, and that is minus 1. Finally, our z is determinant of augmented matrix for z divided by original determinant, which is 12 divided by 4, and that is what? 3.